In this video, I'm going to walk you through problem 42 in chapter 3. This problem resembles the tuition problems we went through in class. It is multiple period investment problem. A woman has initial fund of $356,000. The beginning of the investment is January 1st, 2001, and with the goal of growing money to $500,000 by December 31st, 2001 and plus 5. Therefore, the investment horizon is 6 years. There are 4 funds to invest on. Fund A has 7% yearly return, maturity 1 year. Fund B, 16% return, 2-year maturity. Fund C, 24%, 3-year maturity. Fund D, 32%, 4-year maturity. Given that there are 6 years to invest the money, Fund A is available to invest for every year. But Fund B, the last year she can invest in Fund B is year 5. For Fund C, it's a year 4. Fund D is year 3. If she invests Fund B in year 6, the problem is the money will not mature on the December 31st, 2001 and plus 5. Therefore, it's not feasible. Given that the number of times each fund can be invested, you can formulate the problem. First of all, define the decision variables. That AI represents the money invested in Fund A in year I. Similarly, BI represents money invested in Fund B in year I. The objective is, given the description of the problem, if she does not need to invest all the inheritance to have $500,000 at the end of year 6, she will find another purpose for the remainder. Again, based on the sentence, investment horizon is 6 years. And the objective is to minimize the fund needed to reach the goal. Therefore, the objective is to minimize the total money invested in year 1. In dynamic problem, you want to visualize how the money in successive years are related. Once the money is invested in year 1, it's going to roll over next year. So let's look at the logical relationships among the decision variables. Let's look at beginning of year 1. The total money invested should be less than what she has. That's $356,000. In year 2, A1 will mature by the end of year 1. Total available money is $107A1. There are 4 options to invest in all 4 instruments. 107A1 is the money available, and over here is the money available to invest. It must be flowing, money flowing should be greater than or equal money flow out. Similarly, for year 3, money invested in A in year 2 now matures. It grows to 1.07A2. B1 also mature, grows to 1.16B1. In year 3, she can still invest all 4 instruments. Again, flow in should be greater than or equal flow out. Similarly, the logic applies for year 4, year 5, year 6. In year 4, the money available to invest is 107A3 and 1.16B2, 1.24C1 minus available to invest in year 4 is just instrument Fund A, Fund B, and Fund C. So continue till year 6. She has a goal of growing money to minimum $500,000. So there's a year end of 6 constraint. The money mature is 1.07A6 plus 1.16B5 plus 1.24C4 plus 1.36D3. Has to be greater than or equal 500,000. She wanted to spread out the investment in each year, so each fund should not have more than 120,000. So that's represented by this constraint. And then another constraint is non-negative constraint for all decision variables. So that's it, the set up this problem. Next step is to use Excel spreadsheet to generate solutions. On the top part, it's all decision variables. So you can see first 3 years, it can be invested all 4 funds. Year 5, B should not be invested in D, and year 5, only A and B funds are available to invest, can be invested in fund A and B, and then year 6 will be just in fund A. The coefficient of objective functions is 1, 1, 1 because you minimize the total investment in year 1. Here, its objective value is simply sum product of the coefficient and the decision variable. Over here, you put the cash flow balance for all 6 years. So year 1 over here is initial investment, should be less than or equal total available. Again, in Excel, you will have left-hand side and the right-hand side. Right-hand side has to be all constant, and the left-hand side typically is the sum product of the constraint. Let's look at solver. Set up solver, just tell solver where you put objective. You put in T5. This is a minimizing problem by changing the decision variables. You put decision variable from cell B4 to cell S4 and the constraint. Because here it's all less than or equal, so you can use array to set up the constraint. Left-hand side, less than or equal right-hand side. The year 1 cash flow constraint and the constraint of no more than 120,000. Click solve and then generate solutions. Based on the solutions here, she actually will have some money left. All it's needed is $324,000 and then $198. And this is the investment plan over the 6 years. That's it for this problem.